students, let's continue with the phases of compiler. So far we have discussed about the phase 1 lexical analyzer, phase 2 syntax analyzer, phase 3 is a semantic analyzer. Now let's see the phase 4 intermediate code generator. So what's the phase code? Sorry, the phase 4 was intermediate code generation. So it is the representation of final machine language code that is produced. Intermediate code generation, it is the representation of final machine language code is produced. Okay, so far we had seen the analysis phase. Now we entered into synthesis phase. So the synthesis phase is concentrating on the machine dependent. So this is everything is machine dependent. So far the phase 1, phase 2, phase 3 or the language dependent, but from phase 4 onwards this is machine dependent. This phase bridges the analysis and synthesis phases of translation. So it acts as a bridge between the analysis as well as the synthesis. So let me explain with an example. The same example, let's take new value is equal to old value plus fact into 1. Okay. So how the intermediate code generator will produce this equation, how it is going to be converted. So far it will tokens to the parse tree. Parse tree is going to check in the semantic analysis whether it is following the correct rules or not. Now the intermediate code generator is going to convert this high level language into the machine. Means that what? Low level language. So that is machine dependent. Let's take ID1 is equal to IDE2 plus IDE3 into 1. So here the intermediate code generator is going to take the temporary values. Temp1 is equal to, so it's just taking temp1 in is equal to int, suppose the real 1 number. 1 is represented as temp1 and temp2 is equal to IDE3 into temp1. So this statement is represented as temp2 is equal to IDE3 into temp1. So now coming to temp3 is equal to, so temp3 is equal to IDE2 plus this complete is temp2, temporary 2. Finally, ID1 is equal to temp3. So what is temp3? ID2 plus ID2. Temp2. Temp2 is nothing but ID3 into temp1. Okay, temp1 is nothing but 1. So this is the equation. Intermediate code generator. So with the help of this intermediate code generator, we are converting this statement into ID1 is equal to temp3. So now let's see the fourth phase. So what is the fourth phase? The fourth phase was the code optimizer. Sorry, fifth phase. Phase 5. That is code optimization. So what this code optimization will do? So this is an optional phase describing to improve the intermediate code. So it is used to improve the intermediate code so that here in the code optimization, the output runs faster and takes less space. So how it improves the intermediate code operations and how the output runs fast and takes less space? It removes the unnecessary code lines and arranges the sequence of statements in order to speed up the program without wasting the resources, the CPU resources. So that's why here the output runs faster and takes less space. It's just the main aim of this code optimizer is to remove the unnecessary code lines and arrange the sequence of statements in order, so that the program will be speed up and without wasting resources. Let's see the example of the code optimization. So by taking the above intermediate code, whatever we get, that is the temp1 is equal to IDE3 into 1. Okay, and that will be converted into IDE1 is equal to IDE2 plus temp1. Means the complete that equation, whatever we are taken, new val is equal to old value plus fact into 1. So by avoiding all the unnecessary statements, it's just converted this statement into temp1 is equal to IDE3 into 1. So this is taken as an IDE3 and IDE1 is equal to IDE2 plus temp. Okay, so this fact into 1, it is taken as a temp1. Okay, and old value it is taken as IDE2 and IDE1. This is a code optimization. And coming to the next phase, that is the last phase, phase 6. Phase 6 is the code generation. So what this code generation do? It is the last phase. The code generator translates the intermediate code into a sequence of relocatable machine code. So it just translates the intermediate code into sequence of relocatable machine code. Relocatable machine code. So these are the different phases that are present in the compiler. Let's see the code generation example also. Just take the same example so far whatever we have taken. The example for this is code generation. IDE1 is equal to IDE2 plus IDE3 into 1. So how it is going to converted into the final target code. So whatever the compiler will use the target code with the help of the code generation with the final stage of the phase. That is move R1 comma IDE3 multiply, this both multiply R1 immediate address 1 and then move R2 comma IDE2. After that add R1 comma R2. Okay, so and finally move the result into IDE1 comma R1. So this is assembly level language, that is a low level language which the compiler converts. So the compiler, what compiler is doing? The compiler converts high level language into low level language. So this is the final statement. Okay, and what is the symbol table that we are seeing here? The symbol table manager, it is a data structure all the data structures are maintained in the symbol table manager throughout all the phases of the compiler. Okay, here all identifiers name along with their types are stored here, and the symbol table makes it easier to compiler to quickly search the identifiers records and retrieve. So whatever the identifier records are there, and they are retrieved easily with the help of the symbol table manager. And the error handler is used to handle the errors. So these are the different phases that are present in the compilation process. Thank you.